All right, usually when we do one of these, we're digging through, huge reports or big articles. But today, we're going to do something a little different. We are going to try and understand the future of education just by deconstructing one single thing: the title slide for a high school math course. Seriously, let's see what it tells us. And that's really the big question here, isn't it? It might look like just a simple image, but trust me, every single element on it, from the words they chose to the pictures in the background, it was all put there for a reason. And if we break it all down, we might just uncover a blueprint for how to teach the next generation of innovators. So right off the bat, this is the promise. And I want you to notice those words. It's not just challenging, it's visually engaging. That immediately sets the stage for something that isn't about, dry formulas on a chalkboard. It hints at something dynamic, something modern, and something that's actually built to get a student excited. Let's see if the rest of the slide backs that up. Okay, first things first, you gotta look at the name. The title of anything is like the first handshake, right? It's your first clue about what this whole thing is really about. And this one, well, it's very specific. The title is Advanced Math and Abstract Reasoning. Pay attention to that word and. It's not one or the other, it's both. This deliberate combination is our first huge clue about the whole philosophy behind this curriculum. And this difference is absolutely key. On one side, you've got advanced math. That's the what. It's the hard skills, the complex formulas you need to know. But on the other side, you've got abstract reasoning. That's the how. It's the logic, the problem solving, the ability to actually understand what you're doing. So when you put them together, it's pretty clear this course wants to teach students not just how to calculate an answer, but how to actually think. So we know what they're teaching. The next logical question is, who is this for? And, the slide gives us a pretty clear answer on that too. The course is aimed at Level 3 students in grades 9 through 12. So right away, we know this isn't some beginner's class. This is for high schoolers who are already on an advanced track, the kind of students who are ready to be pushed way beyond the standard curriculum. These are the kids being prepared to be the next generation of engineers and scientists and, well, problem solvers. Every great course, every great project, really, it has a mission, a little statement that just captures its ultimate goal. And this one is incredibly ambitious. Powering innovation and understanding. I mean, that is a bold statement. It doesn't just say teaching calculus. It makes the claim that this course actually powers innovation. But how? What does that even mean? Well, the answer is kind of hidden right there in the phrase itself. See, it's a two-step process. Step one is understanding. You can't innovate with tools you don't actually get, so the foundation has to be a really deep, conceptual grasp of the math. And only then, once you have that, can you move on to step two, innovation. That's the end game, taking that deep understanding and using it to create new things, to solve really tough problems. So the big takeaway here is that true innovation isn't just some random spark of genius, it's something you build on a solid bedrock of knowledge. All right, now let's talk about the visuals, the background. The description mentions sleek, futuristic animations. This stuff isn't just decoration, it's not just eye candy. The specific images they chose are telling a story about what this kind of math is actually for. So first, you see these dynamic graphs. And I mean dynamic, they're moving, they're changing, they're not the static drawings you see in a textbook. That immediately points to the study of complex systems, of how things change over time. And then that abstract idea of change is immediately grounded in the real world with visuals of financial markets. It's basically telling students, hey, this math, this is what drives the entire global economy. From there, the course seems to move beyond flat, two-dimensional shapes and into 3D. We see these rotating geometric proofs, which signals a focus on spatial reasoning, something that's absolutely critical for fields like engineering or architecture or design. And finally, the whole thing is tied together with these subtle coding symbols in the background, which explicitly connects mathematical logic to the literal language of technology itself. So, when you put all four of those visual cues together, a really clear picture starts to form. This curriculum is all about real-world application. It's got an interdisciplinary focus, connecting math to finance and tech. It's obviously got a tech-forward approach, and it puts a huge emphasis on visualization as a tool for understanding complex ideas. Okay, so we've torn apart the title, the mission, the target audience, the visuals. But why does any of this matter? I mean, what's the big takeaway from spending all this time on a single slide? Because from this one single slide, a complete blueprint for the future of advanced education becomes just stunningly clear. And that blueprint shows us that this isn't just a math course, it's a whole philosophy of learning. It's ambitious, right? It's designed to challenge the brightest students. It's applied, making sure that what you learn doesn't just stay in a textbook. It's interdisciplinary, which is huge because it recognizes that real-world problems are never solved by just one subject. And maybe most importantly, it's future-focused. It's built to give students the reasoning skills they're going to need for jobs and for problems that might not even exist yet. And that leaves us with one final, and I think really powerful question. If one single title slide can lay out such a clear and compelling vision for the future of math, what would happen if we applied that same ambitious, applied and interdisciplinary thinking to history or to literature, to all the other subjects we teach? What could the future of learning really look like then?